we're going to take notes again, and we're going to continue. I forget what we talked. What did we title it before? Writing equations. So we're going to. This is still lesson 2-1. Oh, beautiful green. And this is going to be writing equations part 2. And today's date. And I'll get the part 1 up in case you guys were absent. Then you can copy that down. Today's date is 11/2. Gosh, that's hard to write. 15. Okay. Oh, it. Okay. So one thing I wanted to share with you is a vocab word, a formula, which you guys have used formulas over and over again. We didn't write formula down. But we did, that's why we're calling this part 2, because we're going to continue. Yeah. Yeah, we didn't use a whole lot of space there, so you could continue on the other notes. That would work too. Okay. So what is a formula? It's basically a rule for the relationship between certain quantities. Don't you love how vague that is? And the reason quantities. And the reason why they can't be more specific is because we have so many different formulas. And so we need to understand all sorts of different formulas. So those certain quantities when it comes to area of a rectangle are length and width. When it's talking about the perimeter of a square, the quantities are 4 and the length of a side. So the quantities change based on what it is. So again, it's a rule for the relationship between certain quantities. Okay. So I'm going to give you a sentence in English, and your job is to translate it into math. We've got the area of a triangle equals the product of 1/2 the length of the base and the height. So what's going to make a formula different than a regular equation is that, generally speaking, we're going to have more than one variable involved in here. Okay? So how are we going to represent, well, first off, what is our word that tells us to write the equal sign? This one is about as obvious as it gets. Equals, right? So we know anything that comes in front of that is going to be on the left of the equal sign. Anything that comes after that is going to come to the right of the equal sign. So equals is over there. So how do we translate the area of a triangle? What do you think we're going to use to represent that? And remember, this is a formula. Oh, this is easy. What do all area formulas start with? What? Hello. Wake up, people. I know it's Monday. I know it's gloomy. Michael. Huh? Nope. Nope. What do all area formulas start with? Joey? Nope. We're talking the left side, folks. The left side says the area of a triangle. How do I represent the area of a triangle, the area of a square, the area of a circle, the area of any geometric shape in all area formulas? Alicia. Which one in particular?
Oh.
Johnny Ray. It's an A. Yeah, area, we use A. Okay. Now, after the equal sign, we have a lot. It says the product of. So what is that going to tell us to do? So we're going to have some multiplication going on. And then what are we multiplying? What's it say? half the length. So how do we write what the length, it's not just the length, it's the length of the base. What do we use to represent length of the base? Think back to what that formula looks like. Okay, Patrick?
Height.
Dude, we cannot describe the length of the base as the height. I'm asking you, how do we write the length of the base in the formula for the area of a triangle? Bryce? We use B, okay? Whew, you guys are scaring me a little bit this morning. Okay, and then it says, and the height. So how do we represent height when we're talking about formulas? Jackie? We got it now, okay? Now, what you need to understand is they don't just willy-nilly pick out letters. They pick out letters that kind of represent the pieces of this particular shape. So when I write, I have area equals, and then it says the product of. And remember we said the product of when we have the word and, that's saying what are the two things that are getting multiplied. Now the one thing that I didn't do anything with was this guy, because a half is a half. We don't have to translate that, and they kindly wrote it in numbers, so we already know what that looks like. So what I'm going to multiply is 1/2 the base times the height. Now because anytime I put a number next to a variable next to a variable, all that means is multiplication. So normally when I hear that phrase, the product of, what should I be doing to what comes after that phrase? What did we say? Any phrase that says the operation of, what does that normally tell us to do? Not to do it twice. Nope, it's not a switcher phrase. Tells you parentheses, but in this case there's nothing else being multiplied, so we don't need to use that. So that's how you come up with the formula for the area of a triangle. Okay, so notice it has a lot of variables in it. Can we solve that right now? No, we need to know 2 of those pieces of information in order to solve for the third. Okay, all right, so the next thing they're going to have you do is to go the other direction. And they're going to give you an equation, and your job is to translate it into a sentence. Oh, let me try. I'm going to try different words. Translate into a verbal expression. And because we're doing it on paper, we're actually going to write the verbal expression. So we're just going to do an example of this. I have a 6 times a z minus 15 equals 45. So now what I need to do is come up with a way of writing this. So, somebody want to give it a stab in the dark? Okay. Joy, I saw your hand first.
6 times z minus 15.
Okay, hold on. I can only write so fast. 6 times z minus 15 equals 45. Could somebody come up with a different way of translating this? Nico.
6 times z take away 15 equals 45.
Okay, Michael, you got one too?
6 times a number.
Well, they tell us what the number is, so we have to use z. So I see where you were going on that one. Oops. You want to try again?
Never mind.
Okay, he's saying never mind. Okay, Natalie.
15 deducted from 6 times z is 45.
Okay, 15. I was lazy not writing my numbers out. 15.
Deducted from 6 times z.
Listen to you. Nice use of new words. So what did you say on the other one? What did you say for the 6 and the z?
15 deducted from 6 times, or multiplied times by z is
And then what was the last part?
45.
Okay. So we can say equals, we can say or is equal to. I'm going to be, I'll write it out all the way. I liked what she used here, a switcher phrase that changed the order of the 15 and the 6 multiplied by z. The key word there was from. So she came up with an ingenious way of saying subtracted. She said deducted. I like that. Okay. Patrick, one more?
45
Okay, the only thing with starting with 45 is that that's how I would translate it, with 45 out in front, but that's not what the equation looked like. But I totally see what you're doing there. You're using symmetric property. But I think I would just give you a word of caution on that one. Okay? Joy?
Would you be able to do 6 times the number z?
You could say that. The one thing I didn't hear anybody say is the product of 6 and z minus 15 is equal to 45. So we can even, instead of using word times, we could say the product of. And then we would say 6 and z. Okay. All right. So that's one thing. Now here comes the last thing. Now I'm going to give you some information, and your job is to come up with a scenario that would go with this. Okay. So I'm going to give you background information, and I'm going to give you an equation. And your job is, can you come up with a story that would translate into the equation? Does that make sense? Okay. So we're going to say create a scenario for the following information. Gosh, sounds like they're doing PE right outside our door today. So we have this information. T equals time for Maxine, or time that Maxine drove in each turn. Well, maybe if I could spell. T plus 4 is the time Tia drove in each turn. And then the equation that you need to come up with a scenario for would be T plus the quantity T plus 4, 2T, I'm sorry, plus the quantity T plus 4 equals 28. By the way, notice that if you're using T, I tend to do it more like italic so it doesn't look like a plus sign. Some people would just go to capital T as well, and most people wouldn't choose T. That way you wouldn't have issues. Okay? So T is the time that Maxine drove in each turn. T plus 4 is the time Tia drove in each turn. And then the equation we want to get from our scenario is 2T plus the quantity T plus 4 equals 28. All right. So what does 2T represent? It does represent the total time that she drove. What else does it tell you about Maxine? Which means what? She had 2 turns, right? She drove twice. Okay. And then what about the T plus 4? She had 1 turn. What else does it tell you about Tia's time driving? What does the T plus 4 tell you about Tia's time driving, Joy? Okay, let's talk about that. He came up with a good idea, but I'm curious about his labels. He said that T plus 4 means that Tia drove 4 minutes longer than Maxine. Okay? Thinking about driving, how do we measure driving? There's 3 components, right, for driving. It's a distance that you're traveling. What else? You've got a speed. And do you remember what kind of label you would have for speed, Nico? Just miles is your speed? Yeah, it's got 2 components. It's got miles and hours. Because we're driving, our time would be based on hours as opposed to minutes. Okay, so keep that in mind. You got to think logically about how would I measure speed in a car. Okay, it would be miles per hour. Okay, all right, or kilometers per hour, depending on what country you're in. So let's see if we can come up with this scenario. We've got one person who takes 2 turns. We've got somebody else who takes 1 turn, but she drives 4 hours longer than the other person. What's the 28 represent? So I'm hearing total time. What else could T stand for? Anything else that could be? Okay, so sounds like total time. Okay, so now we have total time. Who can come up with a story that involves Maxine and Tia driving, that involves how many times each person drove, that involves Tia's time versus Maxine's time, and it involves the total amount of time that they were driving? So let's think about this. 28 represents what? Which is in what label? Not miles per hour, hours. So they're taking a 28-hour long trip. That's pretty long, okay? So we got to think about them driving a pretty large distance. Okay, so where can we say? What can we say that they went on? Say again? A trip from California to Oklahoma? That might be a little too far, but that Florida is way too far. That's cross country. It'd be way more than 28 hours, believe me. Unless you're my dad and he drives like nonstop. He's crazy. Okay, so let's do that. Maxine and Tia. And this is where if we had time, I'd give you guys iPads and you could find the travel times between one place to another to make it as realistic as possible. Maxine and Tia took a trip. Let's do that. From, did you say Illinois? Iowa to Florida. Okay? What can we say next? That would make us write 2T. Joy? Okay. So Maxine drove for 2 turns. And what can we talk about Tia? 1 turn, but what's special about Tia's time? Okay. And Tia drove 1 turn, but she drove 4 hours longer than Tia. Okay. And then how do we get no, that's both Maxine, sorry. How do we get the 28 in? We say the trip took, I'm going to just change your words around, a total of 28 hours. Now we have to ask a question, right? Because what's the point of writing an equation unless we're going to solve it? So what variable would we end up getting as part of our answer in this situation? What would we end up getting all alone on one side and numbers on the other side? Joy? Okay, we'd have T. What does T represent? Okay. Okay, miles per hour is speed. Is this asking about speed? Okay, it's just dealing with time. So look, we have a definition for T, right? What does it say the definition for T is? Okay, so T stands for the time that Maxine drove in each turn. How can we take that definition and now make it a question so that our reader knows what they're solving for? We want them to get T equals some number. So what is it that they're actually solving for?
How long is each of the turns?
Not each.
How long is...
If we get,
How long did each of them have?
it says T. T belongs to one person.
How long was one of Maxine's turns?
Okay, that works for me. How long will it, can we say it was each of Maxine's turns? Okay. So, wow, I'm thinking about all the years I've taught math, and we've never talked about coming up with what the story was behind a word problem. We've always been given the word problem, and our job was to come up with the equation. So that's kind of a new twist with Common Core, is the fact that it wants you to come from both perspectives. Here's an equation. What could the potential problem be in that's the equation you would have translated? Here's a problem. What's the equation you could translate from that? Okay, Michael?
For a test, would we have to do this, like, write a...
You may. And the reality is, I may have 50 different responses, and that's okay. As long as yours makes sense, that's good. Now, there was alternatives, because you're right. We could, Bianca, solve for both of them. But just initially, when we get T, that's dealing with Tia. But knowing Tia's time, Maxine's time, then we could also figure out Tia's time. So you're right, it could be for both. All right, that's it.